Ladies and gentlemen, we are delighted to welcome you to the 29th inaugural lecture, proudly brought to you by the Faculty of Graduate Studies of the University of Moratuwa. To officially commence today's lecture, I respectfully invite Professor Jagat Manatunga from the University of Moratuwa to introduce our Professor of the Day, Professor H.R. Pasindu from the Department of Civil Engineering of the Faculty of Engineering of the University of Moratuwa.
Good evening. Dean, Faculty of Graduate Studies, Professor H.R. Pasindu, my dear colleagues who are present here physically and those who are connected online, ladies and gentlemen. On behalf of the Department of Civil Engineering, it is my privilege to introduce my dear colleague, Professor H.R. Pasindu, an accomplished academic and professional in the field of transportation engineering. Professor Pasindu earned his PhD in civil engineering from the National University of Singapore in 2012 and holds a BSc Honours in Civil Engineering from the University of Moratuwa. He is a chartered engineer and a chartered member of the Chartered Institute of Logistics and Transport. Currently, Professor Pasindu serves at the Department of Civil Engineering at the University of Moratuwa, where he has been a faculty member since 2012. He has also held the position of Director of the Engineering Research Unit, ERU, of the Faculty of Engineering. His international experience includes serving as a Fulbright Scholar at the Georgia Institute of Technology, USA, and as a visiting scholar at the National University of Singapore. Early in his career, he worked as an executive engineer in the Road Asset Management Division in Singapore's Land Transport Authority. Professor Pasindu has also consulted for global institutions such as the World Bank, Asian Development Bank, and World Health Organization on projects related to pavement management, road safety, and infrastructure planning. Professor Pasindu's professional involvement extends beyond academia. He holds leadership positions in several key organizations, including his role as a council member of the National Council for Road Safety in Sri Lanka, and has been a council member of the Asian Pavement Engineering Society since 2019. He is also the Vice President of Education at SILT Sri Lanka and serves as a member of the International Education Standards Committee of CILT International. In addition to his professional endeavors, Professor Pasindu is an accomplished researcher with numerous publications in leading journals and conferences in the highway engineering domain. He has received several prestigious awards, including the American Society of Civil Engineers, ACE, Transportation Engineering Journal, Outstanding Research Review Awards, the Fulbright Advanced Research and Lecturing Award, Delft Road Safety Scholarship, and multiple University of Moratuwa Research Awards. His ongoing research focuses on development of sustainable road asset management systems and road safety. It's again my privilege to introduce Professor Pasindu. So to you, Professor Pasindu.
Thank you, Professor Manatunga, for the kind introduction. Dean, Faculty of Graduate Studies, Head Department of Civil Engineering, colleagues from the Department of Civil Engineering, and all those who have joined online. It is with great pleasure that I deliver the inaugural lecture after assuming the position of Professor in Civil Engineering. So I base my topic that is on paving the way forward, balance economic constraints with sustainable road asset management, based on the research that I have conducted over the last decade and the various projects that have been associated with both in Sri Lanka and overseas. My main aim is to give some background on what this is, what road asset management is, and how this can be used or adopted under the current economic constraints to maintain our road network in a sustainable manner. So just to get an overall picture, transportation and sustainable development goals are very much intervened. the two goals, goal number 9 and 11, are directly related to transport. But beyond that, transport systems also indirectly affect several other goals: education, um, hunger, health, the economic growth. So there's the indirectly transcend to a lot of the goals. So developing a sustainable transport system is of paramount importance. Just a brief overview of road network in Sri Lanka, because I'll be talking about this problem from a local context. So it's good to have an idea of what it is, what the road sector is all about. In Sri Lanka, we have around 120,000 kilometers of roads. One of the highest road densities in similar economies in the region. So what governments have done over the years is built a lot of roads in the country. These are divided into about 5 categories, depending on who's managing the Road Development Authority, the provincial RDAs, or the local councils. So all in all, we have 120,000. Majority of those roads are basically local roads. Those are the roads that are controlled by the local councils. Then you have the A and B class roads, as well as the expressways, which come under the RDA, and then about 18,000 kilometers of roads, which are managed by the provincial road development authorities. So what is the significance of this? As you all know, as I mentioned earlier, 85,000 of our road network is low density, low volume roads, mostly in rural areas. And this is where the critical issue is, because these are managed by road agencies, local councils, who doesn't always have sufficient funds, nor the technology, nor the knowledge to maintain these effectively. But at the same time, these roads are the main links between those rural communities and their access to education, jobs, health, and other economic needs, right? And studies have also shown that there is a very strong correlation between rural infrastructure investments and improvement of the socioeconomic indicators. For example, poverty alleviation and access to good transport is very high correlation, very highly correlated. And if you look at the impact, rural infrastructure has an impact nearly 3 times higher than that of the overall road network. So, for example, if you go and upgrade a road in a village, potentially it has 3 times the impact it would have if you do the same type of work in an urban or suburban area. So this is in a way why governments in Sri Lanka over the last several decades have invested heavily on this aspect. Now, what is the constraint? All of this needs a lot of money, and the real issue is, how would you guarantee when you go and invest in roads that would lead to economic growth? Because if you do not do the correct investments, if those investments have technical shortcomings, if in the long run there are budgetary shortcomings where you cannot maintain these properly, and the maintenance, the governance factors are relaxed. For example, the loading regulations are relaxed. And also the natural externalities that come from road construction, that is on safety and air pollution. So these will add up and create economic burdens to the society in the long run. So although in the previous slide we said that road construction and development generally leads to improvement in socio-economic indicators, if you do not do it properly, it can have a negative effect. So the whole idea of sustainable road asset management within the economic constraint is ensuring that this does not happen. So this is the moving ahead. This is our primary question. Road sector investment must ensure priority is given to roads that maximize economic benefit, at the same time ensuring negative externalities are minimized and available budget is used effectively. So has government of Sri Lanka been committed on this issue? The short answer is yes. If you look at, especially from 2006-07 onwards, the expenditure on highway sector has increased steadily, and it accelerated towards the end of 2014-15, and of course with the economic restrictions, COVID, and the economic crisis, it sort of died down. But during normal operations, when the government was functioning normally, they did spend a lot of money on roads construction. This is epitomized by the fact that 2019, just before the economic crisis, out of all the major sectors that the government spent money on, look at health, irrigation, energy, education, housing. So these are the major cost sectors for the government. They spend more than 50% on roads. Right? This is not transport. This is not money that you spend on railways and bus operations, CTV and all that. This is just primarily for roads and bridges. So if you look at this, you start to wonder: are we overspending, or are we getting the best out of these large sums of money that we are allocating on the roads? And another interesting fact is that even the money that we borrow, let's say from the typical donors that we get, ADB, World Bank, and JICA, although the attention is often given for expressway construction, we do spend a lot of money on rural roads, right? And this is more than all the other types of roads that is considered in the last 20 years. So these are some of the interesting facts just to show the dynamics of how road sector investments happen and how the government decides the priorities, and then we can question whether these priorities are correct, right? Or we can also question, do we have a better way of spending this amount of money, right? Can we get a better outcome with these billions of rupees spent on the road sector? And moving ahead, the critical question is, do we have the fiscal capacity to continue this level of spending? So these are the questions I try to sort of answer throughout this topic. And now we come to the core aspect of this lecture, that is on road asset management. I will not spend too much time on explaining these details, but for the general audience who may not be aware of this concept, so road asset management is basically taking asset management principles that is adopted in almost all sectors: energy, facility management. All the sectors have some asset management system in place. You look at the same principles of developing inventory, monitoring the condition, looking at the evaluation of alternatives, looking at how much money you have to spend, developing some plans, and identifying which plan is the optimal, and going ahead and implement it. So in a nutshell, that is what asset management is about. It sort of controls or quantifies, use quantitative techniques to make decision making move from subjective to objective, right? So typically when you are looking at asset and making decisions on the asset, there are a lot of subjective decisions made. But if you have an asset management system, you move towards an objective decision making that is based on quantitative analysis. One of the key things here in road asset management is, what we are trying to achieve is reducing the life cycle cost of the asset, right? So as you go along in this lecture, these terms will refer to often, so I thought it's best to give a brief explanation of what they are. And as with all asset management systems, what happens is with time, the asset deteriorates, right? The condition deteriorates, and you have asset in good condition, and it continues to deteriorate. And at a particular point, if it deteriorates further, you cannot use that asset, right? So then you have to intervene and go and repair or replace that asset and start using again. So that is the life cycle we are talking about. And during this period, you have different interventions. You can do preventive maintenance, that means the minor repairs that you do. And then if there's major repairs, you do corrective maintenance, and if it comes down to a failed state, you have to completely rehabilitate it or replace. So in a road, we call it the pavement. In a technical term for road is pavement. So there are various indicators that we can use to monitor this, right? So monitor this performance measure. These are various indicators that we can use. One of the common ones is roughness, that is the unevenness of the road. And throughout this lecture, for simplicity, I will refer to roughness as the predominant indicator for measuring the performance of a road. So what is the challenge in this? If you let the asset deteriorate, by the time you intervene, your cost of intervention, how much money you need to spend to restore the asset to the original condition, is going to substantially increase. Now, this is what was established in USA by the Federal Highway Administration. So we did a similar study in Sri Lanka to see whether it follows the same pattern. So you look at roads in different parts of the country and look at their deterioration. As I mentioned, this is the performance measure. As the road becomes older, it deteriorates. So a brand new road would look like this. A moderately old road would, like 5-year-old road, would look like this with the roughness value of around 5, and a very poor road after about 10 years would look like this, right? Just to get an idea what this roughness is all about, right? So when you say roughness is 8 or 10, you're looking at a road like this, right? When you say roughness is 2, you're looking at a very smooth road. The repercussion is also quite significant. Initially, due to the first 5 years of operations, your maintenance cost is very, very low, right? And then all of a sudden, from year 6, 7, 8 onwards, if you do not intervene, your maintenance costs going to go up exponentially, right? So it's like a lot of the time you talk about the economy, it crashes slowly and all of a sudden, right? So it's the same sort of phenomena. Initially, it deteriorates slowly, and all of a sudden it becomes unmotorable, right? So this is what we are trying to guard against. We are trying to intervene at the correct time so that we don't end up spending 5 times. Now, if you look at the cost here, it's about 200, and here it's about 1,000. So within about 2 years, very likely that we are going to spend about 5 times more if we do not go ahead with the correct interventions to maintain. And this is just an introduction on the roughness, because I use that term often. So roughness is basically unevenness of the road. That is what you feel when you drive on the road, the vibration or the bump that you feel. That is basically what we measure using the term roughness. So I will not spend too much time on that, just to clarify the terminology. Now, how do we select the maintenance strategy, right? So traditionally, if you look at a Pradesh Sabha or a local council, what they do is they let the road deteriorate, right? They let the road deteriorate, and only when it becomes impassable or unmotorable, they will go and intervene to maintain. The problem with that is, right, if you look at in these simple charts that I've shown here, so if you allocate a poor, very low budget, over time you will not be able to maintain all the roads. So gradually, let's look at a 20-year cycle. Your overall road condition continues to deteriorate. So every cycle you are intervening. The intervention is shown here. You're reducing you're improving some of the roads, but that's not enough. When you look at the overall network condition, it continues to deteriorate. And this is what we envisage in Sri Lanka. If we do not intervene at the right time, if we do not allocate sufficient budget at the right time, over a period of next 10 years, we are going to have a highly deteriorated road network, right? But that doesn't mean you have to do maintenance every year. That is also not cost effective, right? So it's about balancing between these two extremes, right? You don't want to go to this extreme, which is shown in yellow, and try to maintain all the time, which is also not needed. So it's finding the optimum balance between not doing anything, do nothing, and overdoing your maintenance. And this also shows that this is a typical pattern what we experience in a country like Sri Lanka. Let's take, for example, typical Pradesh Sabha road network. First year they won't do anything. They wait until everything's quite bad, and they borrow a lot of money, get a lot of funding, maintain it, and after that they will forget about it, right? So the almost next 10 years, they hardly do any maintenance. They wait until everything deteriorates again to a very poor condition. And in the 18th year, they had spent a lot of money, more than what they did before, to restore the condition to the original, acceptable level. Now, if you look at this cycle, you could see a highly variation, right? High variation in the spending. So for a government, it becomes very difficult to plan their cash flows, right? So if all these 200, 300 odd local councils come up with these highly variable demands, budget allocation demands, it becomes very difficult for the central government to allocate money, sufficient amount of money to conduct the appropriate maintenance. So we must guard against this. And also from a life cycle cost point of view, if you delay your maintenance too long, that means you let it deteriorate. That means your maintenance threshold is lower, higher. That means you let it deteriorate more. Overall, over a period of 20 years or 15 years life cycle, you will always spend more money, right? So that is guaranteed. And this is the optimum region that we are trying to target, where we say, if you do this, if you intervene at the right time over a period of long period, we'll always spend 50% less, right, than what we would have otherwise spent. So we are trapped in this cycle right now. If you look at our road sector, we borrow money, let's say from ADB or something, we go and rehabilitate all our roads, and then we wait for another 15 years, 10 years, do nothing, and again we have to borrow money. Right? So whereas if we had a proper asset management plan, we would always save much more and do more with the funds available. So one of the things that we have to first establish maintenance threshold, as I mentioned earlier. When the asset condition continues to deteriorate, your maintenance cost goes up. So it's up to the agency to select where do you want to intervene, right? You want to let it deteriorate a lot, or whether you want to intervene earlier. And it all depends on the analysis, right? So you can't say one answer is correct. It depends on your road network, the existing condition, your overheads, and all these things. So the message is you have to establish your own maintenance thresholds. So this is just to explain the next step. I've used a very simple optimization model just to elaborate what goes on after that, right? So, so once you understand what is going on in your road network, you have to find out the optimum program, depending on the number of options or maintenance plans you have. And even a simple, linear programming model can be used for this. You don't need to go for sophisticated computation methods. These will give you substantially effective results, which I have shown you. And these are some of the asset management tools use these for the analysis, and I just want to illustrate that this is what are the options available, right? So the optimization model basically addresses all the steps that you would normally follow in a asset management system, looking at the budget, looking at condition assessment. You can develop different models for that, and the optimization analysis and the maintenance plans, all are part of this model. Now, developing a maintenance program. Now, maintenance programming is now, if you look at, let's say for any road, you have R options, like 3 options. If you have thousands of roads, let's say you have 500 roads, you will have billions of combinations, right? So R into the power n, you will have billions of combinations. So you can, this is not something that you can exhaustively compute and find out the best. So this is where optimization methods to solve these optimization problems are needed. If you look at a very simple problem like this, you could see that this is for a very small road network. This is the solution set, right? This is the solution set. So as you improve your road condition, right, you will have to spend more money. You will have to spend more money. So if you let the road deteriorate, your cost of maintenance will come down. But within this solution set, an optimization model, what will do is it will select what is within the constraint, what is feasible, right? The first feasibility constraint is your budget. Of course, any road agency will not have unlimited access to funds. So that is one of the constraints, and they will also have a target. They will have a goal. Okay, I want to maintain our road network. On average, the road network conditions should be 3. So within that, you find, okay, what is within the budget constraint, what is the best that I can achieve, right? So this is what we are trying to solve in a typical optimization model, just to elaborate it clearly so that you understand what's going on. And now we look at why this is needed. This is something that we did with our local engineers. What we did was we assigned them a road network and then said, okay, if you have 50 million to maintain this, use whatever the method that you are using right now, and try to select roads for your maintenance strategy plan, right? And then after they select we calculate the network IRI, that means overall, on average, what is the network condition. And you can see there's high degree of variability, right? So some engineers actually do quite well. Some, the methods that they're doing is average, some are quite underperforming, right? Of course, if you have enough money, this variability decreases because if you have money, you don't have to think too much, you can maintain everything. But when you do not have, let's say you have 50% of your total requirement, that is when you have lot of suboptimal results. And what we are trying to demonstrate here is that using a simple optimization model, you can always do better than what you are currently practicing in your day-to-day work, right? And this is even more relevant if you don't have sufficient budget allocation. But of course, if you have substantial budget allocation, the importance reduces. But still, there's room for improvement where you can maximize the usage of the funds available. And this graph also shows how, from a planning point of view, how you, when you continue to allocate money, how you can improve the network, and also it shows diminishing returns in the sense that, say you spend more than 500 million on this road network, the improvement that you're gaining is marginal. So you have to question if for some reason you are given excessive amount of money, right? Some networks it happens. You get, for some networks you get too much money, for some networks you get very little. So we have to guard against that. So, right? So if you do a proper analysis, you can easily find out at which point you can, what is the minimum budget requirement for you to maintain your road network, right? So these are some of the additional parameters that we should incorporate in planning our maintenance. The next question is, there are a lot of roads that are typically given priorities. Maybe the road leads to a school or a civic center. Maybe some important industries are located. So do these models accurately capture that? A lot of feedback we get all the time is these models doesn't really translate to what we need. Right? So to prove that it is not the case, here we show that the roads that given high priority by them, by incorporating priority indices in the model, we can select them first, right, as you go along initially. Though these roads that are given higher priority is always selected, right? So these also can be accommodated quite easily through optimization or analytical approaches. And now we come to the question, now, do we always need to use these sophisticated computation techniques? Can't we use a simple prioritization, a simple ranking? Would that give you good results? The answer is yes, right? If you look at your traditional methods of fund allocation and just going from that, if you go from that to a simple ranking, right? You look at the condition of the roads, rank them and select based on that. You can also achieve quite a significant improvement, right? And then of course, if you want additional improvements, there's always the more complicated computation techniques that you can adopt. But for us, for my opinion is at least rather than doing your simple subjective decision making, at least go for a prioritization approach to achieve these improvements. At the same time, if you have very little funds, I mean, if your total demand is 100%, if you have less than 10% of your budget needs, then of course it doesn't make too much of a difference whether you have go for analytical, these sophisticated optimization methods or not. A simple ranking thing will also give you the same sort of outcome. And at the same time, the other extreme is when you have all the money that you're requesting, which is also very rare, then also you can easily do the maintenance. But the reality is often road agencies are in this range, right? So they have about 30 to 40% of what their budget requirement is, and that is where these analytical methods has a huge role to play. Now we go to the next question. All this time we were talking about the day-to-day maintenance work and how that can be managed with the analytical methods, objective type analysis. Now we are moving a step further. We are looking at investment. That means if you get, let's say, a loan or a fund allocation and you want to select out of the entire country, what type of roads or which roads you should select for upgrade. And for this, we use the concept of system cost, where we not only consider the road agency cost. All this time we were looking at the road agency's cost, how much money they have to spend, but we look at the road user cost. That means all the vehicles that are on the road, what will happen to them if the roads are deteriorating? Their operating cost is going to go up. It will slow down, and that will cause delays, and that will lead to an economic cost. So this was also established through a couple of research studies done a few years ago. You could see as the road deteriorates, you see a slowing down of vehicles. And also, this is also very non-linear in the sense that initially up to a certain level, the difference is not that much. But all of a sudden, you see a very significant reduction in speeds the moment the unevenness or the deterioration exceeds that threshold. Right? So this is the critical phase that I always talk about. You let it happen for 5 to 6 years without any interventions and assume next 3-4 years will also be the same, but the breakdown happens quite quickly. So in terms of road deterioration, in terms of maintenance cost, as well as in terms of the impact on the road use. So this is, I'm going to reiterate why we need to have sound asset management systems in place. So the overall system cost concept, I mean, this is very popular. You have one function decreasing, the other function increasing. So there's always been optimal point, right? That's where you have to intervene. And in this also, we are looking at that when the road condition reduces, the road user cost increases. When the road condition improves, it reduces, but the cost of rehabilitation increases. So you find the balance where the total transport cost is the lowest. And moving on with that, we extend this to the life cycle cost analysis concepts. These are also commonly used in infrastructure and other engineering disciplines. We are looking at the life cycle 20-year period of asset. Over that period, how much of the road user costs, that is vehicle operating cost, travel time, crashes, and how much of the maintenance cost that has to be incurred. And the present value of that is calculated as life cycle cost. I'll just show you an example, a real case in a rural road in Sri Lanka. So if you look at this, the routine repair, that is what is normally happening. They're comparing that strategy, that maintenance strategy, against asphalt concrete road. That means they want to upgrade this road. Right? They have a normal metal tar road, and they are thinking, okay, what would happen if you do asphalt concrete? The conventional wisdom would say that, okay, this is a good thing. People will get benefited. More people will travel faster. There will be economic growth. But actually, if you calculate, it's actually negative. Right? So this is not an isolated situation. This happens in a lot of the cases. And this is where these sustainable road asset management principles have to be followed to make sure your investment decisions are wise. So I've just taken a snapshot I've taken out the roads because this is not. I just want to elaborate the point. These are from a road network in Anuradhapura. Typical funding plan. You select the roads, looking at what can be, how much money you need for that, and you could see a lot of roads are not giving a very high EIR, right? So some are negative, and even those roads that are giving some positive values is not significant, right? So investment planning, we typically say that internal rate of return of around 10-12% is acceptable. Anything less than that, it's not easily defendable as a wise investment. So you could see that although we have a lot of investments on roads, not all roads are actually leading to substantially high economic returns. And this is further reinforced when I plotted all the roads that were part of that investment strategy, plotted the road condition and the economic internal rate of return. And you could see overcapitalization. That means you have a substantial number of roads that does not need to be upgraded. What you need to do is the routine repair as it is. But it is being upgraded because of what is perceived generally as road construction or road upgrading will naturally lead to economic benefits, which is not always the case. Right? So we must guard against overcapitalization. That means over-designing roads beyond traffic needs, implementing overly frequent maintenance schedules, and building roads in areas with low demand or economic potential. And this is a real concern for Sri Lanka in the last 10 years. Due to various reasons, we have selected roads that may not have been actually necessary for improvement. So in conclusion, what I want to reiterate is subjective ad hoc road maintenance planning, selection of roads for upgrading leads to suboptimal resource allocation, which has been demonstrated. We need to prevent overcapitalization, invest in road upgrading where the net economic benefits are very low or negative. Relevant authorities must always use objective analysis for decision making at all levels, whether it's local, provincial, or national level. And also from a society's point of view, local communities must understand that road upgrading to asphalt concrete, we generally use the term carpet roads, isn't always necessary to fulfill the socio-economic needs. A well-maintained gravel road or your traditional metal tar roads could still serve the purpose. Right? So the people's perception has to also adjust. The demand that always the road has to be carpeted or concreted doesn't always work. What should happen is you have convinced that the money that you save from these unwanted investments can be repurposed for the infrastructure improvement of, for example, in agricultural area, in warehousing facilities, irrigation, education, health, supporting local industry. There are so many things to do, provided that you identify the priorities and make sure your investment has substantial returns. So thank you very much for this opportunity, and I believe that I will conclude.
Thank you, Professor Pasindu, for your insightful address on sustainable road asset management. Your expertise truly sparked our gathering today. In acknowledgement of the valuable contribution to Professor Pasindu through his insightful lecture, I'd like to invite Professor Jagat Manathunga to present the lecture memento to our esteemed professor for the day. Alongside, I would also like to invite Professor H.R. Pasindu to accept the lecture memento. Thank you, Professor Jagat Manathunga and Professor H.R. Pasindu. As we draw to a close, I would like to take a moment to acknowledge the truly supportive sponsors of this 29th inaugural lecture. Cargill's Private Limited, the event sponsor, Daily FT, the print media sponsor, the Sri Lankan Scientist, the social media sponsor. And with that, we officially conclude the 29th inaugural lecture, and thank you all for joining with us today. We truly look forward to seeing you at the 30th inaugural lecture. Have a wonderful day ahead. Thank you.